doing the test review for Chapter 2, Part 2. And we're going to do questions 1 to 8. So it says, determine if this relation is a function. So when it looks like this, it's very hard for me to see that it's a function. So what I do is I write it like this. 7 is the input and 5 comes out. Negative 8. If I push negative 8 on the vending machine, negative 4 comes out. If I push 2, negative 2 comes out. And if I push 3, negative 6 comes out. So what I want to know is, does only one thing come out? So here there's no repeats. And look, only one thing comes out each time. So yes, it's a relation. Let's look at the next one. Same thing. So it's hard for me to see it like this. So I'm going to write it like this. If I push 5 on the vending machine, a 4 comes out. If I push 3 on the vending machine, a 4 comes out. If I push 4 on the vending machine, a 3 comes out. So we always cover up this because we don't care what comes out. Is there a repeat here? Nope. And only one thing comes out of each one. So yes, this is a function. It's okay if these are repeated here. We don't look at them. Okay. Now is this one a relation? I push 4 and a 5 comes out. I push 7 and 8 comes out. I push 12. Does only one thing come out each time? Yes. So it's a relation. Let's look at the next one. If I push 7, 2 things come out of the vending machine. So if I push a 7, that means I get a chocolate bar and a bottle of water. That means the vending machine is broken. So that's not a function because of this right here, because 2 things come out. That's not good. Okay, next one is question 5. So is this a function? So what we do is we have the vertical line test. So all we have to do is take something vertical, that means up and down, and we go like this. Does it only touch in one place? Yes, it touches the function in one place, so yes, it's a function. Next one. Does it touch in only one place? No, it touches in more than one place. So this is not a function. Okay, next one. It says give the domain and range of the relation. So because it's a line, this is going to go on forever and ever and ever up, and it's going to use all the positive x values, all the negative x values. So for x, which is the domain, it's going to be negative infinity to infinity. Sorry, let's write x here because x is the domain. Now for the range, which is y, it's going up forever, so it uses all the positive y's. It goes down forever, it uses all the negative y's. So the range is also this. So which one is it? Here. So a straight line, a line, the range and domain are these. Okay, let's look at the next one. Can you see it? Yes. So let's look at x, the domain. So here's x. This goes on forever and ever and ever in all the positive x's, okay? But, right here, okay, right here, it doesn't use any negative y's past this. So can we see what that is? It's going up by 2's, 2, 4, 6, 8. So it's between 4 and 6. So if it's between 4 and 6, that must mean it's negative 5. So here is negative 5. So this graph exists at negative 5 to infinity. But just wait. It exists here. It can be equal to it. So it has to be a square bracket. Okay. So now we do y, the range. So this keeps going up forever and ever and ever and ever and ever. So it's using all the positive y's. It's going down forever and ever and ever and ever, so it uses all the negative y's. So it's going to look like this. So which one is that? Looks like maybe it's this one, yeah? Range, yeah, so it's this one. Well, look, they have a round bracket and a square bracket. This one means it can be equal to 5. This one means it has to be greater than, it can't be equal to 5. It means it has to be greater than 5. Whereas here, because it actually touches 5, it can be equal to 5, so it must be the square bracket. Okay?